Hello students, good morning. Today we see the exercise 4.1. The previous lecture I was explained that what is the standard form of the quadratic equations in one variable. Now we see the example on the base on that one. See, as I revised simply, ax square plus bx plus c is equal to 0. It is the standard form of the quadratic equation in one variable. And see what conditions are here. A, b and c. This a, b and c are any real numbers, but a is not equal to 0. Okay, this is the condition for this quadratic equation. Now see, what is question number 1 says that, see, check whether the following are quadratic equations. Means whatever the questions are given here, examples, that example you have to solve and try to write it in the standard form. If we can able to write that example in the standard form, then you can say that is the quadratic equations. Otherwise it is not a quadratic equations. See that first example is done. See, the second one. Second example is given x square minus 2x is equal to minus 2 into 3 minus x. Okay. See, this example we have to solve and try to write it in the standard form. See, now solve. It is what? X square minus 2x is equal to, it is minus 6 plus 2x. Then x square minus 2x transposing here plus 2x, sorry, minus 2x plus 6 is equal to 0. Now again here, for that, therefore x square, it is minus 4x plus 6 is equal to 0. Now compare. It is ax square plus bx plus c is equal to 0. Here the first term is x square, second is x, and then constant. So what? It is in the form of what? Quadratic equation, standard form. Suppose we compare it, so we can it is which is in the form of ax square plus bx plus c is equal to 0. Therefore, given equation is what? Quadratic equation. Quadratic equation like this. Okay. Now see the another one. So I take the 6. Okay. 6 one, that is x square plus 3x minus 1 is equal to x minus 2 whole square. Then x square plus 3x minus 1 is equal plus 1. X square plus 3x plus 1 is equal to x minus 2 whole square. Now again you have to solve this one. So it is given there what? X square plus 3x plus 1 is equal to, it is a minus b whole square. So x square minus 2 into x into 2 is what it is? So it is this 4x plus 4. Okay. This is what? A minus b whole square. It is a square minus twice ab plus b square. This is what we have to use here. So like this one. Then x square plus 3x. See here, x square and x square. So we transposing. So x square minus x square is what? 0. So this get cancelled here. What is remaining here? 3x plus 1 is equal to minus 4x plus 4. So it is 3x plus 4x plus 1 and it's minus 4 is equal to 0 after transposing the terms. So what about this one? It is 7x minus 3 is equal to 0. And it is in the form of ax square plus bx plus c. See, x square is missing here. X square term is missing. Though we write it is in the form of, suppose if we write it 0 x square plus 7x minus 3 is equal to 0. Now we try to write in the form of the x square plus bx plus c is equal to 0. But what our condition says that a is not equal to 0. Here is a is 0. So therefore it is not in the form of ax square plus bx plus c is equal to 0. Okay, so like this. So we write instead of here, what to write? which is not in the form of ax square plus bx plus c. Therefore, the given equation is not a quadratic equation. Okay. So we write here which is not in the form of ax square. So I am writing here which is, or it is not in the form of ax square plus bx plus c is equal to 0. Therefore, it is not a quadratic equation. Okay. Like this, we have to solve the question number 1. Remaining question you have to solve. Now see the question number 2. See, second question is again the important thing. In starting of this chapter, I said that the quadratic equations are generally used in the daily life procedure. Okay, means what the word problems are given, that problems you have to write in the mathematical form, means in the quadratic equation form, and then you can solve. How to solve it, that is the further. Okay, that solving method I'll explain later on. Now see the question number 2. What is B? 4.1. Represent the following situation in the form of quadratic equations. Okay, see first question. Read out carefully. It is a technique of the word problem solving. First, you have to read carefully that word problem. Get what is the fact is given and try to write in the mathematical form. That we can do. The area of rectangular plot, question number 1. The area of rectangular plot is 528 meters square. The length of plot in meters is 1 more than the twice its breadth. We need to find the length and breadth of the plot. For finding the length and the breadth, we have to make an equation. We cannot solve here. See what to do. First, let breadth is equal to x meter. Okay, if breadth is x meter, so condition is given here for that the length of the plot is 1 more than twice its breadth. 1 more than twice its breadth. So therefore, what is the length? Length of plot is equal to 1 more than twice its breadth. Okay, twice breadth plus 1. So it is called 1 more than twice its breadth. These are the meters. Okay, then therefore, now so the first one. The area of rectangular plot is given 528. So you know what is the area of rectangle? Length into breadth. Okay. So here, therefore, area of rectangular plot is equal to length into breadth. Okay. Now area is given. So area is already given there. 528. So it is 528 is equal to what is length? That is 2x plus 1. Into what that x length, it is what breadth. Just solve this one. If you solve this, you will get the quadratic equation form. Just see, 528 is equal to it is 2x into x, 2x square plus what will it is x. So therefore 2x square plus x minus 528 is equal to 0. Okay. It is in the form of what? Quadratic equation. So we write here again, which is the required. It is required quadratic equation. QE stands for quadratic equation. Okay. So like this one. Don't solve it. This is second question. See question number 2. What is the situation is given in that example word problems that you have to identify first, and then you have to write in the mathematical form. See question 2. The product of two consecutive positive integers is 306. We need to find the integers. The product of two consecutive integers. Consecutive integers means that is 1, 2, 3, 4, 5. These are the one, and so on. These are consecutive. So let the consecutive integer with the x and x plus 1. Let you see. Let two consecutive integers be x and x plus 1 These are the two consecutive integers. What is the condition? The product of two consecutive integers is given 306. So therefore, what is the condition? The product of these two, x into x plus 1, is equal to 306. Then you can solve for that. X into x, that is x square, plus x is equal to 306. Now write in the form x square plus x minus 306 is equal to 0. And see, this is again in the form of this one. It is in the form of what? Quadratic equation. So this is our required quadratic equation to find out these two consecutive integers by given conditions. Okay, like this. Next question. See, question number 3. Just read out that and find out that. We will know how to do this one again. See, Rohan's mother is 26 years older than him. The product of their ages in years 3 years from now will be 360. We would like to find the Rohan's present age. Rohan's mother is 26 years older than him. And what we find out? Rohan's age. So let Rohan's age be what? X. This today's Rohan's age. So we can start with that one. Let question number is what? 3. Let Rohan's present age is equal to, suppose, x years. Okay, so what about his mother? His mother is 26 years older than him. Means what? Therefore, his mother's present age, for that 26 years more older means what? 26 plus x years. Now condition is given 3 years from now, means after 3 years. After 3 years. After 3 years, so this is the present age of Rohan. His mother's present age is 26 plus x years. So after 3 years, what? After 3 years, Rohan's age is equal to what? X plus 3. That is what? Years. And his mother's age after 3 years is what? 26 plus x is the present age after 3 years plus 3. This is what? Years. Is nothing but what? 29 plus x. Yes. Okay. Now see the condition. What is given there? The product of their ages after 3 years will be 360. The meaning is that product of these two numbers is what? That. So therefore, x plus 3 is the Rohan's age after 3 years, and 29 plus x, his mother's age after 3 years. This product is given 360. Okay, just solve this one as you know this bracket. So it is you multiply and try to write in the form of this one. So that is what required things. Okay, you know very well how to solve this one. So I am leaving this for you to solve. Okay, solve this example. Okay, further example you have to solve and find out the required quadratic equation for this example. Okay. Last question. See. Next. This is fourth one. See what is given here. A train travels a distance of 480 km at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. Okay, a train travels a distance of 480 km at uniform speed. So what would be here? And what we find out? The speed of train. So let's take the speed of train with x km per hour. So we can start with that. Let speed of train is equal to x kilometer per hour. Okay. Now this x kilometer per hour the distance to be covered by this speed is uniform speed. By this speed, distance covered is equal to 480 kilometer. So what time is required to cover this distance at this speed? As you know the formula, this is what time is equal to distance by speed, right? Time is equal to distance by speed. So therefore we have to find out time is equal to, it is 480 by x, 480 by x, or that hours. This is the first condition. So at this uniform speed, the train covered 480 kilometer in this time we can get it. Now condition is given again, but the speed is decreased. Speed is decreased than is x. Definitely that train travel same distance in less time. Time required is what? Less. So then if decrease, you can write here decrease the speed. Okay, how much decrease? It is an 8 kilometer per hour, or that 8 kilometer per hour. So is equal to what? X minus 8 kilometer per hour. Now this is a new speed, decrease in speed. Okay, so distance covered is same, 480 kilometer. So what time is required for this one? Again there is time is equal to distance by speed. So distance is same, 480 kilometer, and speed is what? X minus 8. What that? Hours. Okay, now this is the time, this both are the times. So time distance, time difference is given what? 3 hours. So if that train decrease its speed 8 km per hour, so same distance that train covered by these hours. Okay, so difference of these 2 hours, how much? 3. So the condition is what? Then therefore 480 x minus 8 minus 480 by x is equal to 3. The difference of these 2 times is what? 3 hours. And then we have to solve this one. As you know how to solve this, just multiply and cross multiply, you will get your answer. Answer means we have to find out the quadratic equation, that required thing. Let me solve it, no problem. See, yes, so 480 is what common, okay, for convenient. So it is 1 upon x minus 8 minus 1 upon x is equal to what? 3. Then 480. Now solve this one is easier to you, that is x into x minus 8. This is x minus 8 is equal to 3. So 480, then x minus x plus 8. Here is what? X square minus 8x is equal to 3. So it is what? 480. Cancel, it is into like this. Okay. Into what? 8 divided by x square minus 8x is equal to 3. Transpose here. Should I here? See. Okay. See, then what? 480, that is into 8 is equal to x square minus 8x into 3. Okay, then solve this one. It is what? 3x square minus 24x. It is how much it is? 800, 88 is 64, 4, 6 carry, 84, 84 plus 6, 5. Okay, 3840. Then, okay, therefore x square minus 24x minus 3840 is equal to 0. This is the quadratic equation form, so it is required quadratic equation. So it is 3. It's divisible by 3 again, so you may divide by 3. So this is what required quadratic equation. So like this. Just once again read out the word problem and try to solve it your own. Okay, this is very easier thing. Next period we will see how to solve the quadratic equations by the different methods. Okay, so see you then. Thank you.